Okay, let's start. Okay, so note, now given the fact that we have only cross section, we want to think of uh, creating a panel based on our cross section, but the proposed solution more in terms of creation of synthetic panel, right? So what is the synthetic panel? It's the concept is something like quite old. It's being introduced by Deaton in 85 and further developed by Dang and Lanzhou in 2013. And their main purpose was to look at the income poverty over time in countries where you do not have any availability of panel data. You will observe the same thing. There is a database known as, I think, WIIID, World Income Inequality Database. Exactly there, you will face the same problem, that it is not exactly a panel in that way. So what we do here, we want to consider the identification of population cohorts in cross-sectional periods, and I can either pick the socio-economic or I can pick demographic characteristics. Once this population cohort I have identified, then from each one of the cohort, I basically calculate their average. Okay, so that's the way the process goes. So I collapse, I first decide about the characteristics of the socio-demographic characteristics. Then once I identify the cohorts, I take the information from each one of the cohort by its average value. That's exactly what I do, okay? And Ik is nothing but average value of the variable I who lies within the cohort K, and then IIK represents the value of the indicator I for individual I in the cohort K, and NK represents the population in the cohort K. So for example, I decided to take age. I decide that the cohort would be age group of 3. So then I pick everyone in that particular age group. I start with 20, 20 to 22, 23 to 25. In that way, I calculate. So what I do then, that I think of it that I now, my variable of interest is the labor supply, the hours of labor supply, right? For each one of these group, I then calculate the averages. Of course, the averages would be nothing but the mean, and hence I divide it by the number which lies, total lies in that group, which is NK. Clear? Fine. So that's my construction of synthetic panel. Then the variance within cohorts is minimized through its technique and keeps cohort homogeneous across the time period. So original sample is regrouped from individuals' observation, because I said the age of different individual is available, and I picked a group of 3, and then I create the synthetic panel of individual cohorts, right? Where the values representing the mean. Remember, I'm calculating the mean of you are lying between this age group, how many hours you have worked in a particular week. So the DID estimation, then I'm going to do exactly on the same functional form like I did previously. So here I have YIST, then I have IT, and then ST, and then my interaction term with the set of control. But look, the way I then want to think of it. My YIST is nothing but from the previous slide. I have generated this guy IK. So my YIST is nothing but labor supply or the average labor supply in the age group of 3. Belonging K is group, S is state, T is time period. Clear? Same thing I want to do it with K and T. Got exposed, did not get any exposure. Because I got exposed, why? or the first one is the time, right? Before and after. Then I lied in that group which got the exposure. So S and T. Then I have the interaction of the first term, which is the time, and then the treatment. And my interest would lie again with my beta 3. Remember, now my phi KSTQ again is the averages of those characteristics, right? So the average of other characteristics. So something like it could be average wage that particular age group of 3 or within the band of 3 they have earned. Clear? Fine. And then the normal, I have the error term. Is it clear? Right? So that's how I do it. So thus, these cohorts keep the average information of similar individuals, right? Similarity here in my example is in terms of age. You can do it in terms of other demographic characteristics, okay? Estimation between baseline and follow-up period will match the same cohort before and after the social intervention, right? So intervention took place. I want to match you, the cohort, before the intervention and after the intervention, okay? And then this matching of cohorts with the same information allows the control of individuals over the time period. I hear the only assumption I believe is that the individuals belonging to a cohort would behave exactly in the same way. So by controlling for cohort specific effect, I am controlling for those individuals lying in a particular cohort, right? So in some way you can think about it. Observable characteristics of the individuals could affect the conditional expectation, which is a very critical thing. Violating this way the conditional independence assumption. Why? Because you have certain characteristics that of the individuals that basically can impact the conditional expectation of the treatment effect. So the way then you want to think about it, if that gets affected, then what would happen? The outcome of the untreated observation should not affect their counterfactual condition, right? So there are group of people who did not get the treatment, but the outcome of those guys cannot affect or should not affect their counterfactuals. These characteristics, again, in some way, is nothing but known as the selection of not sample, but the selection on observables, because I have these as observed characteristics of those individuals who are forming the group of K. And then that could be established that to as a new control group through a non-parametric kernel estimator. And then I basically all I do is create this local average to estimate a function at a particular point of time. I can also do something like a PSM. How? Between treatment and control observation in the baseline period. So I did not form it, right? I mean, I form it, but the program did not take place. Sorry. So in the baseline, I first do a PSM, a propensity score, okay? In terms of the kernel adjusted estimator and the generated difference between the treatment and control observation, then I want to use as the weight, my sampling weight, basically, in the DID. Clear? So if I think of my previous, then I basically want to estimate my YIST equation by taking care of the sampling weight. How does the sampling weight would kick in? The sampling weight would come from the generated difference among the treatment and control observation, right? But note it is in the both the treated and the control observation, both belonging to the baseline period. When? That means when there is no treatment. Yeah, fine. So I'm going to come to this a little bit. So the scenario that we are going to look at, sorry, this is, I always make this mistake, sorry. So the scenario that I'm going to look at, I'm not going to look at actually, I'm going to tell you to do it, is here. So here what you want to do, we started working with this. So in Mexico, the going through a divorce for the female can turn out to be a costly affair, right? Because you have the cost of the lawyer, these and that, and these and that, or whatever, right? Other than the mental trauma or mental stress or whatever you talk about. But in Mexico, they call something a system, a program being introduced is known as no fault divorce. So you want to go for the divorce, you'll get some help to get divorced, where the divorcee would not have to pay any cost. Clear? And at one point of time, Mexican government has introduced this as a pilot project only in Mexico City, but not in other places. And they want to try to see that, whether that has any implication. So recall, this is completely exogenous, the policy. So what we started looking at it, given my control group is non-Mexico City, my treatment group is Mexico City. The program took place when the government announced, and then there was no program before that. And we took this cross-sectional data from Mexico. What we do basically, we first pull the data and do a propensity score. Then we create the sample of synthetic panel. How do we create the sample of synthetic panel? By taking age as our variable. So 0 to 5, 5 to 10 in that way. Clear? And we want to look at whether that has any implication on their labor market participation of the female. Okay? So we look at the three different ways of doing it. One, we want to look at what would happen or what would be the probability that they would participate in the formal labor market. What would be the probability that they would participate in the informal labor market, right? And then the last one, where we have the information, provided that they have participated in the labor market, formal labor market, how many hours they have worked. So these are the three variables, and we want to look at the impact of this exogenous policy change on the labor market participation of the female for in Mexico. Clear? Fine. If you look at your folder, I'm sure it is there. So if you look at your folder, which I also have to, there is a data which is joined 2005, 2011. No, of course you have. Yes, you have. You have. Because it's being uploaded. So if you look at this, let me, huh? Yeah. No, this is, I'll just open the do file. G, I think mine. And there is a do file which is known as no fault. You will see that there is a do file which is no fault. I think this is, I have to take up to this out. It would be my G drive now, and this should be, where is that? Maybe day 4. Yeah, you are with me, right? So open the do file day4.do. You will see that the data has a subscript of 60, because recall I told you yesterday that I'm going to use 60% of the random sampling, because it's a huge data set. It's huge, okay, to really huge. So I just took a 60% of the sample and for the demonstration. So what I do, first, of course, this is very simple. I always prefer to use a delimit so that the line doesn't go here and there abruptly. And then I create a log file. I set a seed so that I can perhaps get the same numbers. So I have the pool data. So make sure that this 100 is 10, otherwise it would take perhaps, I don't know for how many days it would run. Okay. So all those replication things, make it to 10, at least in the first few cases, and then we'll come to that. So note what is it. I have a probit on employment, F. That means the employment in the formal sector. Okay. I control that by age, H square. Clear? Married is something like a dummy, whether you are still, in another relationship or something like that. Household head is basically sex of the household head. Household size, as we can understand. And then we have the per capita household income in real terms. So this is the per capita of the household income, right? In real terms. Then we have 4 different dummy: education 1, 2, 3, and education 4, with one of them being omitted as their educational status. Then we have, you see, the dependent Y and dependent M. So that is like proportion of the dependent young and proportion of the dependent adult. So that is how we want to make a difference between the two. Then I have whether the population belongs to the urban area or not. I then want to control for, I dot ent, where they have worked, of course my time, and then the interaction, because the interaction is nothing but Mexico City times the implementation of the program. Clear? And what I do here, I basically run a simple probit, nothing more than that. And I do basically a bootstrap the error so that it doesn't have any bias in my standard error. And all I want to calculate the dy dx, which is the change in each one of the variable, what would happen. We'll run out of time. The do file is there with you, so you can run it by yourself at one point of time. So all I want to do first, and to show you one of them at least, okay? I don't know how long, with the hope that it would take. Oh no. What happens? I know. It's my mistake. Yeah. So I can run from here perhaps, or maybe from delimit. Yeah. So it is running. Just wait for 2-3 minutes. This would not take that long, because it's a desktop, so it should be powerful. The bootstrap started. Or maybe I should get rid of the bootstrap completely. That would make the process even faster if you don't bootstrap it. So 3 of them is done. How many of them done? Quite a bit. 6, yeah. Okay. Let it do, and then I'm going to open something different. I just suddenly remember. Okay. Let the marginal effect being calculated. So this is your basic probit. 4,41,000, almost 4,42,000 observation. Log likelihood, age square, married, household head, household size, income, everything is there. Education, 4 of them. Then the dependency ratio, then whether the urban or rural, then different type of entity like this other states in some way, then when the program got introduced, then basically the interaction of where the program got introduced times when it got introduced. Okay, so that's what it is. So if I do the marginal effect, which should be done very quickly, hopefully, then I'll just break it and do it something different way. This is taking too long and we don't have that much time. Let me see whether I can open it in a different way. Is this the log file? Yeah. Is there a notepad here? Yeah. This is better, right? So you have the do file, I have the output. You can check that here. Fine? Shall I do that? Then it would take a lot less time. Fine? Because it is the same thing. You can see 441.872 and then 0.2030 is your pseudo R square and things like that. Oh no, that file is being destroyed? Yeah, I think so. Because I rerun that with replace command. Hey, so I am going to run a couple of them. I think that got destroyed. I don't want to do this. I don't want to do any one of them. I want to come straight here. I just want to come straight here then. one करके मैं कर दूंगा. ठीक है. Oh, please. It's too long. Shall I break it? It's even slower than my laptop. It's a lot slower than my laptop. I don't know why it is so slow. Did I send this? Yeah. At least one of them, if it is done, then I can go here and do that. Here I have to. And I'm just going to get rid of this bootstrap. That would be a lot easy. I'm just going to break it. This is taking too long. I don't have the patience. Shall I break it? Huh? You will get it eventually. Huh? Yeah. That's a lot quicker. We use MP. Oh no. Oh no. don't want to get into this. Anyway. Is it done? Oh no, I have to break it. I don't have patience now. I'm going to get rid of the bootstrap. I'm going to get rid of the bootstrap. That would take even more time. That would again taking more time. So if I take the bootstrap away, then I'm going to go and get something else, which is this guy, because I showed you 4 different estimates. NN. So this is propensity score, and then I am going to do EB. Yeah. Control C. Otherwise, I cannot show you the synthetic panel at all. Hey. What is it? Matching NN. Let us see matching MD, NN, PS, and here entropy. I have to break it, okay? I'm sorry. So anyway, so you'll get the result. That's not a problem. So what we then do, see, I'm getting rid of now all this bootstrapping. So I'm now, recall I have introduced you 5 different ways to calculate the propensity score. I think I have to install this program first. So just do something like in your Stata window, SSC install. I think K match is the program, because it's already 12:36. Yeah, so done, right? So then go back and I'll show you this. So recall what are the things that we did. Mohanlovich distance, nearest neighborhood, same dependent variable, full employment, right? Or employment in the formal sector, I'm sorry. Then PS, propensity score, except the radius matching, I'm doing everything here. And then finally, the entropy balancing. After I run everything, I want to examine how the matching works in terms of the K-match summarize. So mean I'm going to calculate of the 2 group, treated and the control. I'm also going to calculate the variances of the treated and the control, or the ratio of the 2, right? So a good matching would be something where the mean are not significantly that much different, as well as the ratio of the variances should be very close to 1, if not equal to 1, very close to 1, right? So I can make sure that they are good match. So if I run that, I'll run all of them at the same time. Yeah, so that is what my this is my policy interaction. This is my outcome variable. And these are my controls, right? So this is my control. This is my policy. And yeah, so that is what I'm doing, no? This is the policy being introduced. This is my outcome, YIST. This is the set of control. Recall your summation k is equal to Q2 phi Q, whatever that guy. I am interested in average treatment effect of the treated. And the matching will be done on which parameter? Age? On all of this. I just thought that it could have a curvilinear pattern, nonlinear relationship with the full employment, or even for that matter, not full employment, with the labor market participation. If you are too old already, if your age is very high, you may not want to participate in the labor market. So there could be a threshold where you will stop participating. Even if you look at your basic probit result, without even the marginal effects, you will see that the coefficient of age kicks in with a positive coefficient, but the square of the age has a negative coefficient. You see that? So it says that the participation in the labor market increases with age, or the probability of participation, to be very precise here, probability of participation in the labor market increases with age. Once age reaches a threshold, then it starts declining, and you can actually calculate the values of where the change has occurred, right? Because that is nothing but minus a divided by 2b, where a is your coefficient associated with age and b is nothing but your coefficient associated with square of age. Okay, clear? So these are the set of the controls. I come here and I just start running on full employment. Okay. If you, sorry, huh? Ah, so this is like matching based on Molnovis distance, right? And then the nearest neighbor and goes like that. Yes. Because you want to think of the impact is in terms of interaction. Because these are the guys who got the exposed to the program.
My sense was that we will do first matching, and then we kind of figure
No,
out
we are.
whether that.
That's what you are exactly doing in this process.
But within the same step.
Yes.
So the first variable after this MD would be the policy variable.
After the MD would be the policy
And then
variable.
followed by the control. Okay.
Control. And this is your outcome variable in parenthesis.
And that was the question also I asked. Like here the covariates are the same as the one on basis of which we are doing the matching.
Yes.
Isn't it going to create certain?
No, that's what you should do, because you want to create the covariates, or based on the covariates you want to match, right? Based on the covariates. So your characteristic, you got the treatment, should be very similar to someone else's characteristic who did not get the treatment. And that is the only case I am interested in computing what is your gain given that fact you got exposed to the program. Vis-a-vis a certain individuals with the same characteristics were not being exposed to the program. That's what you do.
What I'm thinking is that, for example, if we are looking at employability, there
Right.
could be certain controls,
Yeah.
which there could be certain variables which may be affecting whether the probability of somebody joining the labor force is there or not.
Right.
Which may actually not affect the characteristics on the basis of which we are doing the matching. So do we need to include all of them?
You can. But in general, the entire way the matching exercise works is matched based on the characteristics. With
Give you one example. Like we have done the PSN for that R&D, the DSIR.
right.
So there, when we did the matching based on, let us say, variables including exports, sales, etc. And then we go and when we calculate the ADT and also control for the same variable.
Yeah.
I really don't know what does it mean.
No, basically you can think of, okay, the way to think about it, that's the entire point of matching. And to do the matching based on certain observed characteristics. And I have observed the same characteristics for control and the treatment group. And I assume the same set of control would have affected whether you belong to a control group or treatment group. So probability of participation in the labor market depends on age, age square, your family income, your dependency ratio, and so on, and your education. It does not matter whether you got exposed to the program or not. right? Whether you would participate 1 or 0. Now that would affect you whether you would participate irrespective of whether you are in the control or treated. Now suppose the program takes place. So given that fact, whether you have participated or did not participate, how does it matter whether the program got implemented or not? Fortunately, you are lying in this group or this state where the program has taken place. And unfortunately, she is in the other group where she doesn't have the access to the program. But remember, your characteristics of participation in the labor market cannot change because you would participate based on this certain number of observed characteristics. That's what it is. And that's what you do in a propensity score. Okay. So if can I? So a basic way, think of it is something very crude way of thinking that if you look at the coefficient of the interaction term, so that was something like positive and significant, which tells that there is something going on in terms of the labor market participation in the formal labor market. Clear? So if I go here and then start running this model, I don't know how long it would take. Huh? No, no, that's okay. It's done, right? Oh no, it's not. Is it? It's too slow. It's too slow. It's not done. Why is it so slow? Internet. Must be internet. Hmm? Must be. It is. It got stuck even here. Huh? Yeah, yeah, yeah. Yeah, so that's done. Good. So now let's run one of them at least. I think this may take some time. Yeah. It would first compute the automatically the bandwidth. Remember my H notation. I think it would go like a little long and then it would definitely calculate it. It's a huge. That's just for the formal, and then you will have informal. And it is still 60% of the random sampling of the actual data set. I mean, actual data set I could not even, I have in my OneDrive. It's impossible to attach it. And this also, I send it, I think by zipping it. I think it goes like 4, 5, something like that. Oh, it is boring. Huh? Really? Oh, hopefully. Are you doing it?
Yes, sir.
Let us see. I think your machine is better.
I run the Probit
Yeah,
without
and it got it very quickly.
without VC and
Yeah, and you got it very quickly. उसको मत करो अभी. Go to that MD thing. कहाँ है आप? हाँ. See, they got the result already. So this machine is slower than her laptop. She got the result. हाँ? आ गया ना?
Another one can do NM since we are doing MD here.
Yeah, yeah. So just repeat the same command, change MD to NN. Oh, it is now done. NN would take more time, by the way, because you see the matching is like NN1. So 1 to 1, it tries to find out.
And then in two also, and then three and four.
Yeah, you can do it.
But when we were trying to put together PSM with DID, there was like this concern that because of selection and observable.
Yeah, you can, I will show you tomorrow that you can have PSM combined with DID.
So that adds a kind of a bias to the DID. That commentary.
I mean, basically, like you need to do lot of different robustness. Like you can do like DID, you can do PSM, you can do like control function approach, which is now getting very popular, and then PSM with DID. So control function is becoming very popular. Maybe we should take her laptop and put it here.
Also that if she gives us permission.
No, because otherwise it would stuck here like this forever.
So have you changed the application to 10 or you need to do some
I did not do any replication. It is now coming. Don't do any replication, please. So look, ATT is 0.017, which is significant at least at 5% level. How do I interpret it? That given the intervention of the program, the participation in the labor market or the formal labor market increases by around 1.7%. Clear? That's the interpretation I can do. If I now do the K-match summarize, you can see there would be a column for the treated, there would be a column for the control, and then there would be a column for treated minus the control. What you want to see there, lot of zeros rather than bigger number. Clear? And then there will be a second part of the same thing. You will see that the variance is being calculated, ratio of one to the other. And in that case, the ratio you want to be closer to 1. Okay? Ratio you want to be closer to 1.
So here we have matched. So matched which were treated, matched yes and treated. See 5365.
Yeah.
They were matched, but they were not treated. No.
No. So they have the matched yes 5365. They could not match 250. Right? So look at, I'll come to that, Ruchi. So you'll see that more or less it's not a bad thing they have done. So the variance, this was the raw, and this is the treated. So actually treatment did better thing because the raw was this, and it start reducing the problem. Clear? Fine. If you go up, they will show you in the mean. So this is the mean of the treated. This is this was the raw data, mean of the treated, mean of the control, untreated, and this was the difference. Are you getting it? And then this is the match sample, like that 5,600 or whatever it is. There the mean is, the difference in the mean is very close to 0 or almost equal to 0. Okay? Similarly here, this is the raw, treated, untreated. I didn't match it. Right? What I started doing it here is the same thing but based on the match sample. So this is my entire data set. This is my match data set. What I want to see this ratio closer to 1 in my match case, and the difference in the mean should be equal to 0 in my match sample. So that means in some way I guess that my matching is not bad. Clear? What you can do, I'll give you this, of course, the do file. You'll see that then it works. I did something like with same thing with NN, nearest neighborhood. All you have to do is change this MD to NN. Here it should be NN. Sorry. Then I did something. Oh no, not here. It should be MD here. I just put NN over here, so that is like nearest neighborhood matching based on 1 to 1. I can do 5, like then up to 5. Okay. Then I can do the PS exactly in the same way, replace the MD by the PS, the propensity score. Last, I do the entropy, is basically by replacing it by EB, again take these guys out perhaps for the time being. I mean, I even cannot have the time, and then you can run that for the entropy balancing. So 4 of the 5 you can do pretty quickly over here, or at least you can try it, right? The other file that I'm going to share, or I have shared it uh, with you previously, I think these files were being shared before, like the day 4 data and the day 4 do. And that's nothing but to do with synthetic panel. Okay. So if I open the day 4 do instead of opening the data, so if I open it with Notepad, all here you need to do that, you see that I want to create this treatment, and then I did something like you have to install a command known as diff, and then here exactly the same way employment F, my outcome variable, my treatment which is here, my ID, or what are the IDs? I have the time dimension, I have the panel dimension, right? What are the controls? Age square, married, household head, household size, exactly the same kind of control, right? I use DS means I want to do the bootstrapping, and how many replication I want to use for the bootstrapping, which is 100, right? So this would give you the synthetic panel results, and the other one would be the cross-sectional, I mean pooled cross-sectional result rather than cross-section. So I have the pooled one over the units over the time period. Clear? Fine. This file was given to you before.
There we are making the synthetic panel, the
Based on the age. Based on the age. Based on the age.
We can do it on size of family or
Whatever. You can create that.
essentially we are looking for some social economic parameters.
Socioeconomic characteristics. You can do it based on even income. You can do it age, you can do it household size, you can do it dependency ratio, you can do it with household income. You can even calculate a principal component of those guys and do that based on the principal component.
But what is the condition we have to meet to identify?
That, like if the age lies between these and these.
No, in terms of selection of the cohort.
What's that you're asking?
No, I'm asking like suppose like in one of the slides you showed no that it should not have an impact on the outcome variable.
Yeah,
That,
yeah,
that should be the condition
yeah,
we have to
yeah, yeah, yeah.
because if suppose age has an important factor on
Factor, then,
employability,
yeah, yeah.
then it will not
No,
be
like that is why we don't generally use like income.
yes.
Income, household income, and your participation, especially given the fact you are female, would matter a lot. So we don't do that. Dependency ratio in some way we can still do, simply because, like after some point of time, you already anticipate that this is your situation in terms of dependency, and then you took the decision whether you would participate or not. So these are the files that is being shared with you. Practice it whenever you have time. I'll stop it right here. Yes.
Which one is for synthetic panel and which one is for cross-section?
The first one,
Is for synthetic?
huh?
Is for synthetic.
This is synthetic. The first one which I showed you, the no fault dot do, that is your cross section. Clear?
Synthetic panel takes only one cross-section and then you
Synthetic panel is a panel, right? Because I artificially created the panel.
but that uses only one cross-section and then
No,
creates
then it is not the, I can have different time periods, right? Because here the way I form the panel is based on the age. Age lies between, for every round, if age is between 20 to 24, 1. 25 to 29, another unit. 30 to 34, another unit. In that way I went. So I have the repeated cross section observed over time period, pick up age as my cohort from the synthetic panel. That's what I do. In the first case, I don't care. I just append the data one after the other and I start running it. I can even think of that this is pooled. I want to have something like repeated cross section, just add as an option RCS. That would tell you that this is nothing but my repeated cross section data. You can do that.
RCS here.
No, in the first one. I mean, you can do perhaps, I forgot. I mean, you can do perhaps, you need to look at the help file for diff and the k match. Yes, which one does? Yes, please.
Sir, can we go to the result of this model
No, I cannot go right now anymore.
during tutorial?
Hmm.
So, sir, can the difference between treated and untreated units after matching, can it come greater than 0 in some cases?
The mean.
Yeah, this difference.
Yeah, the mean can be positive, the mean can be negative. But all I want here is the absolute value should be close to 0. Mean can be positive, mean can be negative, doesn't matter. I mean, difference in mean, of course.
So which one should we use, or we should every and then just report?
I don't understand.
So we have different
Type of estimator. That is where the robustness comes. So a referee generally would ask for, show us whether your result is valid when you change the alternative way of doing matching. And that's what our EER paper is all about. Irrespective of anything you do, you will get the result.
But in that result, last coefficients were insignificant, the two coefficients. The entropy one was insignificant.
We need to look at what was the circumstances. So whether you get 0 vaccine versus at least 1 vaccine, that would be significant perhaps. But 1 versus 2 may not be significant. And then it may not be significant for certain group of people, but for certain group of people it would be. So you'll see that we did lot of characteristics based criteria over there. Whether you belong to vulnerable group, whether you belong to young, what is your age, all sorts of things being done. Yes? Clear? Fine. So I'll close both file. Both file is there in your Guru. Now it is there, no, with them. Yeah. So then that's not a problem. I'll come back, and my comeback would be in terms of your do not save. Our comeback is in terms of your exercise, and I have the data set over here, data table 1, 2, A3. That's the main data set. I didn't give you the do file. I mean, it is there, but it is not being shared yet. Or is it shared? That's okay. So you start running it, and I'll go through the example. I mean, I'll go through it. Fine. This is shared. So the data is shared. Yeah, that's fine. That's what I said. Clear? I don't know what did I do.